Okay, thank you very much, Felix, for the introduction. The title, Entity Linking Historical Document OCR by Combining Wikidata and Wikipedia. So, for our purposes, we need both Wikidata and Wikipedia. This is a short overview about what I'm going to talk about. First, I'll give you a little introduction about why we do this. Then I will do a short excursion to named entity recognition, which is the prior step to entity linking. Then I'm going to talk about named entity linking and disambiguation and how it is done in detail. And then I'll talk a little bit about once you have done that, what you can do then. And finally, I'll give you some resources you might be interested in to look in more detail in the stuff we are doing. Okay, first, a little bit about the Berlin State Library. It's, let's say, a rather middle-aged institution. Founded in 1661. It has quite some inventory, more than 33 million media objects. And of course, we have also a pretty big digital inventory, more than 2.5 petabytes currently and growing. We are part of the Prussian Cultural Heritage Foundation. And since 2007, there is an in-house digitization center which continues to digitize historical books, documents, newspapers. And there are the digitized collections of the Berlin State Library, which currently contain more than 200,000 documents, which can be accessed at that link at the bottom. And these digital collections, this is basically the corpus we are working with. And that is basically the aim of all the work we are doing. Okay, so we have full text of digitized historical documents. So somebody scanned some book. Then we did a layout analysis using machine learning tools. After that, we did OCR using machine learning tools. And finally, we end up with some document where we have full text. Then the first thing we want to do after that is we want to perform a named entity recognition. That means we have the full text and we are looking for the text passages where a person, a location, or an organization is mentioned. And for this, we used a BERT-based NER tagger. We have our own model that has been pre-trained on our digitized collections full text, which is on the one hand historical text. So for example, for German, we have Old German, which is pretty different from Standard German. Most of the text stems from error-prone OCR, so it contains many errors. And so we pre-trained the model in order to get it used to this type of text, and afterwards we fine-tuned the models on actual NER ground truths. In case of German, we use historical and contemporary German NER ground truths, and in case of French, English, and also Dutch, we use combined NER ground truths for all the languages, and we end up with a, let's say, pretty state-of-the-art NER model for these old historical texts. We also have a publication about that, so you might want to look into that for details. Okay, now we are at the stage where we have full text. we have certain text passages that are marked as this is probably talking about a person, this is probably talking about this is probably talking about a place. And now we want to perform named entity linking and disambiguation. And so why do we want to do that? Or actually at machine learning conferences, sometimes people that do not have much experience with NLP, they say, well, yeah, you just have to look up the name. I mean, what's the problem? Yeah, and so let's consider this example. There is some sentence, and well, the red and green markup, this is what the entity recognition system did. So it said there are two persons mentioned in this text. That is a person named Lichtenberg and another person named de Romas. And there are two places also mentioned in this text, Göttingen and Nerak. And now the task of entity linking is to take, for example, this person Lichtenberg and find out, is this a known person? Is it a known entity? Can I find in some authority, for example, Wikidata or Wikipedia, the corresponding entry? And if you do the naive approach and just search for Lichtenberg, for example, in the Wikipedia, you get a pretty large list of people who have a last name Lichtenberg. This is only a small excerpt from the entire list. It's much bigger. And but what we want to end up with in the end is some final list where it says, okay, with a certain confidence, this person is actually Georg Christoph Lichtenberg, and with much smaller confidence, it's rather Ludwig Christian Lichtenberg. And all the other Lichtenbergs in our knowledge base, they are less likely to, even less likely to be the mentioned person. Or maybe one result could be this is no person that is well known and it's just some guy named Lichtenberg. Yeah. Okay, why is this useful? Okay, let's say some user of our library wants to go to the digitized collections and find text that talks about musicians born in Rotterdam. So what we could do then is we could perform a Sparkle query against Wikidata. We get a list of matching entities, and we match this list of entities against all the linked entities in our entire text corpus. And we are finally able to present the user a list of texts that probably talk about people, about musicians born in Rotterdam. This is basically the idea. Okay, before we start with entity linking, we need something that is we call a knowledge base. That is basically the authority the entity linking system works with. And since our entity linking system it performs text comparisons between sentences, this is the reason why we need Wikidata and Wikipedia. So Wikidata is for us the source where we basically get the list of all persons, locations, and organizations we can link against. And for each of these entities, we also extract from Wikipedia the sentences that talk about these entities. And we need these sentences from Wikipedia, this text material, in order to do sentence comparisons to find out, for a particular sentence, if a particular entity could be the one that is mentioned or not. So this is a typical Sparkle query we use on Wikidata in order to find the list of all entities. So this looks for any subclass of fictional organization. We extract only entities, in this case, that have a corresponding French Wikipedia page. Additionally, if available, we also extract the corresponding GND ID, which is the ID in the gemeinsame Normdatei, the entity authority used by many German libraries. And basically, when we have our list of entities that are in the knowledge base, the first step of 3 steps in entity linking in our case is to find a small number of candidates that are possible, that are likely to be the one that is mentioned. So, what actually happens is we take this text passage that we want to resolve, Lichtenberg, and we compute BERT embeddings for this text part, and we did the same for all the entities that are stored in our knowledge base, and the corresponding BERT embeddings have been stored in an approximate nearest neighbor index. And what is done then is we take the text passage in question, its corresponding BERT embeddings, and we do a nearest neighbor search in that index. And all the nearest neighbors in that index are the candidates for the second step of entity linking. So let's say we have this text passage Lichtenberg, and let's say our candidate list is pretty small. We have Georg Christoph Lichtenberg and we have Johann von Lichtenberg in that small list of candidates. Then the entity linking system takes from a database all the sentences in Wikipedia that talk about either Georg Christoph Lichtenberg or Johann von Lichtenberg. And that means we only consider sentences where actually a human, a Wikipedia author, has added a link to that corresponding entity. And we have a purpose-trained BERT model that basically then does pairwise comparisons between the text passage or the sentence in question and all the sentences from Wikipedia. And the output of the BERT model is a probability that is a probability of both sentences, so the sentence in question and the sentence from Wikipedia talking about the same thing. This is basically the output of the BERT model that has been trained on Wikipedia sentences to answer that question. And we do this for this process, this pairwise comparison, for each candidate for up to 50 pairs of sentences in the text in question that mention the entity and the candidate. And basically the final outcome per candidate is a list of probabilities that the references from Wikipedia and the references in the link, the text that is to be linked, refer to the same entity. And finally, the third and last step of entity linking in our case is the entity candidate ranking. What we do then is we have for each candidate a list of matching probabilities from these pairwise sentence comparisons. And we compute this, a number of statistical features from these probability lists, like mean, median, min, max, and various quantiles. And we also consider the ranking statistics over all candidates. And finally, we end up with a feature vector that is fed into a random forest model. And the random forest model computes an overall probability that this text in question mentions this entity candidate. And finally, we sort the candidates according to the overall matching probability and end up with the list that I showed in the beginning in the example. Once you have done that with your entire text corpus, you can do nice things with the information. For example, instead of doing topic modeling with the words in your text corpus, you can do topic modeling with the entities. So instead of words, we just consider entities as the main descriptors of texts in the corpus. And you end up, for example, if you use LDA, then you end up with, for example, with some topic distribution, and you can do a search for a particular entity, and then you end up with a conditional topic distribution. And the nice thing is, if you take a closer look at this conditional topic distribution and you select one of the topics, then you get other entities you might interested in, which are highly related to your entity you were looking for. Of course, you can also derive from that topic modeling a matching list of the documents that are closest connected to the entity you are looking for. So, to summarize, this is the state of the affairs with machine learning at Berlin State Library at the current point in time. So we applied these NER and entity linking methods to roughly 5 million pages of our digital collections. We would like to get these results into the official digital collections presentation portal for search and for discovery and for visualization. Of course, this enables a lot of use cases in the digital humanities. And we are very happy that we managed to get new project funded, Mensch-Maschine-Kultur, which allows us to continue this work. Now it already runs for 1 year, so for the next 2 years. Finally, I would like to give a hint about many resources we put online. On the one hand, we have all the full text of the digitized collections as a SQLite database on Zenodo. We have the source code of the named entity recognition system at GitHub. We have the named entity recognition models at Hugging Face. We have the entity linking source at GitHub and the corresponding models at Hugging Face. We have the knowledge bases that have been extracted from Wikipedia and Wikidata at Zenodo, as well as the source code that is used to extract them from Wikidata and Wikipedia at GitHub. And this alone, even if you are not interested in entity linking software or entity recognition software, these knowledge bases, I could imagine they could be quite useful. And also the topic modeling stuff is available on GitHub. We have a number of publications which evaluate the named entity recognition system and the entity linking system against well-known benchmark datasets. And finally, we have a nice web demonstrator where you can go and play with the entity linking system and the topic modeling, and it's interactive, so you can find out what you interest. Right, that's from me. I hope we have time for questions.
Thanks a lot, Kai. We have room for everybody's very excellent time management this morning, I really have to admit. So yes, we do have time, and oh, Osmar, what a surprise. Has a question.
Okay, thank you. This was a very nice and inspiring talk. I especially like the way you used both Wikidata and Wikipedia to do the entity linking and with language models and so on. Very nice. I was wondering, maybe this is some sort of minor detail, but I would imagine that the time period of what the text is talking about would be important, an important factor in the disambiguation of which person is this referring to. I believe that on your slides also you had listed people living in different centuries, and well, the example text didn't include any specifying anything that would specify the time, but maybe the context around it would provide hints. So I was wondering, is this not a factor, or is it somehow sort of built into the machine learning? Does the BERT model notice that we are talking about a specific century, for example?
Good question. No, this additional information about the time is not put into the machine learning model. However, in case of persons and organizations, we extract from Wikidata the date of birth and the date of inception or something like that. And for most publications, we know the date of publication. And this date of publication can be provided to the entity linking system as a parameter, and it in the first step it filters out all the entities, for example, that have been born after this publication happened to appear. This is nice about time. It provides us with causality. Yeah. So, and we actually use that information in order to filter out everything that just cannot match. Yeah.
More questions? There's a question back there.
Felix?
Hi, thanks for a great presentation. So I have a few questions about the NER task. So the first one is regarding the pre-trained model. Did you train it from scratch, or did you do a domain adaptation? And for the second question, did you try to use specific language BERT for French or English, provided there is enough training samples for those languages? And if you did you find any significant performance difference between using a multilingual or specific BERT language models?
Yeah, okay, thank you for the question. We basically we did not use language-specific BERT models as a starting point. We always used the multi-language BERT model that was trained by Google on, I think, something like 100 languages or something like that. And we did not train from scratch, but we used this pre-trained model from Google, and then we did domain adaptation to the special historical OCR error-prone text of our digitized collections. And then we ended up with a domain-adapted pre-trained model. And finally, we then used language-specific NER ground truths in order to train the model for the particular NER task for the particular language.
I think there was a question back there. No? Oh, sorry.
No? Okay. It's maybe a clarifying question following on Osman's question. Does the natural language processing understand the relationship between the names and places? And the Sparkle query you showed seemed to focus on labels for the entities, and how much relationships between names and places or other attributes might be trying to match up against names and places in the Wikidata.
Okay, so basically the Sparkle queries were really only used, to come up with a list of all entities that are a person in the world and all entities that are a place in the world and so on. And basically the relation between names and places and all the other possible relations that are available in the data. This was basically trained into the BERT model by what we did is, we have Wikipedia, and we have in Wikipedia, I think, like 20 million or so sentences that contain a reference to another Wikipedia article, to another, let's say, person. And what you can create from that is training data for a BERT model by just you take from these 20 million sentences, random pairs, and you ask the BERT model, does it talk about the same person or not? And most of the time it should answer no, and sometimes by chance, we actually had to do something because you cannot do it complete randomly, but in the end it has to learn if we selected two sentences that contain a link to the same person, it should answer yes. And if we selected two sentences that do not contain a link to a common entity, it should answer no. Basically, this was the training task for the BERT model to learn to decide if two sentences talk about the same thing. And the relations, they are implicitly encoded somehow in the weights of the model.
Yes, thank you for your presentation. Also from my side, I'm Kai, I'm from Utrecht. Did you investigate the percentage of accuracy in the end?
Well, in case of the digitized collections, it's difficult because we are working on that, so we want to create ground truths for our digitized collections in order to assess the performance, the true performance on the digitized collections. It's pretty difficult because there's a big range of text material, so very old text. The quality is very different, the OCR quality is very different. OCR quality has a big impact on linking performance. And what we did is we participated in two CLE competitions about entity linking. And there we used entity linking benchmark data sets, which is mainly historical newspapers, in order to assess the linking performance. And for these historical news data sets, depending on which language we are talking about, roughly you have an F1 score. This is a talk on its own, because scoring entity linking is a pretty difficult task, because depending on what you want, should the first match only be considered, or do you allow the first 3 matches to be considered, or whatever, yeah? But depending on how you evaluate, I mean, roughly one can say on the historical newspapers, we have F1 scores between 0.5 to 0.6, depending on what it is, maybe sometimes 0.7, yeah? However, I can report from my own observations in the digitized collections, if you have good OCR quality, and if it's not newspaper text material, but really like a book or something, where also if an entity is mentioned, it is not only mentioned once, but many times, then the system has more things to work with, and then in my personal assessment, the performance is better. But to answer your question, for the digitized collections, we have no true numbers because we miss ground truths currently for that.
Thank you.
Thank you. We're well ahead of time, so we could put in one more question.
One rather specific thing about the Wikipedia sentences. Wikipedia has a convention to only link out to another Wikipedia article when it is first mentioned within the article. Do you try to fish for the other mentions of the concept?
Right. I mean, from a machine learner's perspective, I would if I could have a wish fulfilled, I would like to have all the mentions linked. So far, we really only used the links that are there. I mean, we experimented with heuristics to fish for more links, but so far we did not evaluate that completely. I mean, your suggestion is important, in particular for many entities. You have only very few sentences in the Wikipedia, and for these entities it would help quite a lot, and we definitely thought about it and plan for the future to do something about that, but so far we did not do it.
Okay, thanks again, Kai.